Parallel and series connections. Few of the very basic and fundamental concept in our EEE, but the problem is many of the students, when they're beginning to study EEE, they're really amazed or stuck at it. This is not a very hard concept to grasp, but I will try to show you a few hints so that it may be helpful to solve the circuits. Now, whenever I think of solving any circuit or simplifying a very complicated resistor network, what I try to do is imagine electricity flow as a water flow. It's simplified. Let me show you with an example. So this is a quite simple resistor network, right? It has got a voltage source and 3 other resistors. Now, what you know by now, you should know, the current will flow from the positive terminal. It will flow through the network and it will enter at the negative terminal, right? Now, which one of these resistors are series and which one are parallel, and how do I relate them? Now you see, if I consider that electricity flow is nothing but water flow, what will happen? This flow of electricity will flow from here, travel through the resistor and come to this point eventually. When the electricity has arrived this point, what usually happens? If it was water, it will simply divide into 2 streams basing on the amount of available path or the ease of flow, the easiest way I can explain it. And then this flow branch will travel through this resistor and the rest of the path will travel through the other one and finally meet at this point. From this point, the total amount of current flow will channel back into the battery source. Now let me name them. If this branch is known as I1, this branch is I2, this branch is I3. You probably by now you know the KCL, Kirchhoff's currents division law. So by KCL, I will have I1 equals I2 plus I3, right? That is quite simple. But here's the concept of series and parallel. If the current divides and flows through 2 different resistors, I will consider them to be parallel. So over here, the current I1 has been divided into 2 parallel branches, I2 and I3. So these 2 resistors are parallel to each other. Mind it, they are parallel to each other, not anyone else. Now this same current I1 is flowing through the whole circuit, right? This is the total amount of current. And if I consider that this 2 parallel resistor has been combined into one single resistor, let's say this thing is my R equivalent. Now the current through Req will also be I1, right? And if this resistor was R1, the same amount of current I1 and I1, both the same, they're flowing to 2 different resistors. As because the amount of current is same, these 2 resistors are in series to each other. They'll be considered series to each other. That's the key point. So that's how I imagine electrical circuits, and hopefully next time I will solve some of the problems from the Bolster's book. I know it's not very helpful perhaps using a dining table for whiteboard, but I'll try my best. Thank you.